Okay, good morning, everyone. I hope you all had a good weekend. And how was your computation classes yesterday? Or pumasok pa ba kayo sa labs kahapon? Because I realized wala tayong discussion yesterday sa labs. So hopefully you take advantage of the laboratory sessions so that if something is not clear about a certain problem in the worksheet or a certain concept, you can ask your computation instructors for some advice or some clarifications. Kasi medyo siguro kung nahiya kayo magtanong sa lecture because how many are you here? I think we have 40 or 60 students here. So baka mas gusto niyo yung intimate consultation with your lab instructors, then you can do the consultations with them. But of course, you can also do that in the lectures. Kasi sayang din naman yung opportunity umattend din kayo. So why not ask your questions, right? And again, you are encouraged to ask questions. I don't care how basic those questions sound like. So kung may tanong or hindi clear, tanong nyo lang sa akin. All right. And then, have you guys started working on worksheet 5? I know it's quite early because we haven't finished the study guide for week number 4 yet. But for those who have started with worksheet number 5, did you had some problems with statement 2? I guess there might be some problem with problem number 2. So I would like to propose a correction. So kindly delete the extra sign and the extra cosine for the first and the second term respectively. So please edit question number 2 in worksheet number 5 so that the inequality reads sine x plus cosine x is greater than or equal to 1 for any x between 0 and pi over 2. Kasi parang hindi siya totoo whenever double yung sine at saka double yung cosine. Let's see why. When x is 0, tama ba? Let's see. I'll have sine ng sine 0 plus cosine ng cosine 0. So it's gonna be what? Sine ng sine 0, sine ng 0, 0 plus cosine ng 1. And this is less than or equal to 1. Okay. So false yung statement, at least when x is equal to 0. And I think it will still be false for some x's right after 0. So for x's close to 0, it seems that the inequality is false. So I guess there's just a typo here. So dapat isa lang yung sines, pa isa lang yung cosine, yun sa first and second terms respectively of question number 2. Okay? So kindly take note of that correction before you work on worksheet number 5. I'll try to upload a corrected version perhaps later this afternoon. Pero kindly take note of this. Okay. Then let's see. So last time we started talking about methods of proof, and as I've mentioned, this would be your bread and butter. That's why we will be discussing methods of proof probably until next week. If not, we'll also extend another session week after next. So we have started looking at, I think, with the most basic type of theorems, or basically the most basic type of proofs, which are existence proofs, all right? So we are proving statements that claim the existence of something. So kung gusto niyo siyang ilagay na formal language, so these statements are of the form, there exists an x such that p of x is true, right? So, and then we have said there are two ways on how to write existence proofs for these basic statements. The first one is to explicitly construct or give an example of an x that satisfies the statement p about x. So kapag ka nakapagbigay tayo ng isang x na element ng domain, kung saan totoo si statement p, then that's it. So kailangan lang natin mag-provide ng isang example. And this is one of the rare times that proof by example is admitted. Kasi nga naman, existence lang naman yung sinasabi ng theorem mo, anong statement na gusto mong i-prove. So pag nakapagpakita ka ng isang x that satisfies p, then you're done. And again, that's a classic proof by example, which is a rarity in mathematics. Okay? Kasi laging na-abuse yung proof by example, especially with the amateur students of Math 101. So, yun yung medyo kailangan yung bantayan. And then if you don't want to write explicitly or to give an explicit example, pwede rin namang i-prove natin siya using previously proven facts. So I think we stopped with the example 6 last time, and we presented or we talked about at least two proof strategies. Again, the first strategy is to explicitly construct the number c that is claimed in the theorem. Sabi, kung meron kang function x squared minus 2x minus 3, then there will exist a number c between 0 and 3 inclusive, such that f of c is equal to -1. And again, a proof by example for this basic existence theorem is to find the value of c. And I think we have found one. 1 plus root 3 is such a c that satisfies the conclusion. And that would suffice as a proof. But again, if you don't want to go through the hassle of computing for the value of c, all we are after would be the existence. Hindi nga sinabi nung theorem kung ilan yung element C that satisfies the statement. Sabi niya lang may nag-exist. So why not make use of previously proven facts like the intermediate value theorem? Let's just show that the premises of the IVT are satisfied by the given function over the specific interval given, then we can just appeal to the result of IVT to say, there really exists a number C. So kung mapapansin nyo, yung proof by existence o yung statements involving the existence of something doesn't require an explicit expression for that element X of the domain. Basta ma-prove nyo na kailangang may mag-exist, then that's fine. Okay? So for the rest of today's meeting, we'll be looking at some more sort of existence theorems, pero medyo may kakaiba kasi may iba't ibang combinations of quantifiers involved, right? So in the work text, you will see that they are grouped together according to the symbolic form, okay, o dun sa formal form ng mga statements. However, I don't like to discuss them that way kasi ayokong dagdag pa sa isipin nyo na i-classify nyo siya muna. Wherein you can just read and understand what the statement is about, what it is claiming, and then just do appropriate analysis and do the right proof. Kasi I feel it's really intuitive kung ano yung sinasabi ng mga theorems, and it would be a bit natural on how to go about with the proof once you truly understand what the theorem is all about. So kaya I will avoid identifying them under these classes or this such classes kasi nga hindi naman siya ganun ka-importante. Basta maintindihan niyo yung meaning ng theorem, malaman niyo ano yung claim niya, makakapag-devise kayo ng intuitive method or approach for the proof. Okay? So, yeah. So I hope you don't mind me skipping reading this forms kasi sa exam di ko naman kayo o sa problem set di ko naman kayo ipapag group the theorems together according to the form, or hindi ko na ipapa-identify yung form ng isang statement. So we are just after the proof, and I think the best way to teach proofs is to teach you how to read statements, understand them, and then go by your intuition or your logical intuition. Okay. Now let's see. Example 9. For every positive integer x, x plus 9 over x is greater than or equal to c. Right. So merong statement na kiniklaim, statement P about x, and that is this guy, right? So we want to show that x plus 9 over x is greater than or equal to 6. But however, what are the x's? What is the domain for the x's? The domain here would be the set of positive real numbers. So ang kiniklaim ng statement number 9 is that this inequality will hold for any positive real number. So the attack for this proof is to do a universal generalization, right? Kasi kung mapapansin nyo, for every, so universal siya. Dapat sa lahat ng real number mag-hold yung proof na isusulat natin. So if you want to write a proof, you will assume, remember universal instantiation, we will assume as a generic or an arbitrary element of the domain. So gusto natin, kukuha tayo ng isang random positive number. Wala tayong i-impose sa kanya except yung pagiging positive real number niya. And from there, we want to show that x plus 9 over x is greater than or equal to 6. Okay. Now, let's see how the work text proved this statement. Though looking at it now, mukhang high-tech or medyo, I think, mas komplikado yung proof ng work text. I'm thinking of a different proof, but let's see. So let's read through the proof. So here you see universal instantiation. Since the statement is claiming that that inequality is true for every x that is a positive real number, so the first sentence started with instantiating it to a generic element of the set of all positive real numbers. So we call it x. And then it went on by assuming a known inequality, right? So we know that the square of any real number is always non-negative. So that means x minus 3 quantity squared must be greater than or equal to 0. Okay. And then expanding the left-hand side will give us x squared minus 6x plus 9 greater than or equal to 0. And then bakit mahalaga yung pagiging positive ni x? So meaning there's a reason why the statement is claiming it only for the set of positive real numbers. Mapapansin niyo sa mga mathematical theorems, napaka-minimal ng mga requirements dun sa theorem because we're always going for generality of our theorems. So pag may binigay na premise o mayroong binigay na assumption dun sa theorem, more likely or most likely, gagamitin natin siya sa proof. So there is something wrong with your proof or something wrong with how the theorem was phrased kung hindi niyo nagamit lahat ng assumption dun sa statement, right? So far, wala pa tayong nagagamit about the positivity of x. Now, that will kick in when I decide to divide both sides of this inequality by x, okay? So if I divide both sides by x, we will get x minus 6 plus 9 over x. Then 0 divided by x, that's going to be 0. And that's fine because I know that x is positive, so x cannot be 0. So division will really be defined for both sides of the inequality. And moreover, since x is positive, the inequality won't change, right? And then here we have seen that x minus 6 plus 9 over x is greater than or equal to 0. Remember our goal, we want to show that x plus 9 over x is greater than or equal to 6. And we can get that from here by just transposing the 6 to the right-hand side. Okay. So the proof is anchored in two things. Number one, it is anchored on universal instantiation. Again, because we are claiming this to be true for all positive real numbers x. And then the second foundation of this proof is this known fact, which unfortunately I cannot teach you how to get it kasi I mean, ito yung isa sa mga tricks na hindi mo talaga na ituturo. This will come out of the creativity of yours of you as a mathematician or as a logician. So along the way, mapipick up nyo itong mga common techniques na to. But after you get past this step, I hope that everything else is clear, right? Medyo napaka-specific nga lang nung pagkakagamit o pagkaka-define ng inequality na to para makarating dito sa statement na to. And usually, we find such inequality by doing a preliminary analysis. Maybe in succeeding examples, I can show you how to do preliminary analysis to get what are the assumptions or what the known facts that you will need in order to prove a certain statement. Okay? Okay, I hope that's fine. Now here are some pitfalls or some wrong proofs for this statement. Now look at number one. Number one, ano lang ginawa niya dito? Nag-specify siya ng x equals 1. So think of it as a proof by example, or trying to prove that universally quantified statement via example. So here, he let x equals 1 and then said, oh, x plus 9 over x, I can plug in x equals 1, so I'm going to get 10. Definitely that's greater than 6. Why is it not sufficient to just write this down and say na, oh, I'm done. I have proven the theorem. Bakit kaya hindi siya magpa-qualify as a good proof? Oh, yes, Victor?
Um,
Um,
because sir,
because
you
sir,
only
you
prove that
only
it works for the one. You didn't say for
Uh-huh.
everything else.
Okay, thank you, Victor. That's right. Uh, all the statement here proved ay totoo siya para kay x equals 1. But remember, what the theorem is claiming is that it is true for all positive real number x. So it is not sufficient. Charles, uh, medyo technical. Charles is asking, is it an example of a valid argument but not sound? Uh, Charles, medyo, tawag doon, medyo technical yung pag sinabi nating sound. Uh, Valid itong statement na to, pero hindi siya enough to prove the statement because the statement is for every positive real number x. Okay? Dapat totoo yung statement. Pero ngayon, nagpakita ka sa akin ng x equals 1. So, though valid itong sentence na to, hindi siya sufficient para doon sa hinihingi na burden ng theorem. The theorem is asking us to show that this is true for every positive real number. So, kung gusto mo talaga yung exhaustive, dapat gawin mo to sa lahat ng posibleng real number x which we know to be impossible. Right? Pero hindi ko siya sasabing sound kasi ang definition natin ng sound ay isa siyang argument wherein lahat ng premises ay true. So here, yung premise mo ay true pero hindi siya sufficient to cover all the cases claimed in the theorem. So if I would like to characterize what was done in number one, I'll say it is a valid argument, but it's not sufficient to meet the burden of the proof. The burden of the proof. Okay. Right. How about the next one? And this is something that we will need to be extra wary about. So, tingnan natin yung proof niya. Let x be a positive real number. So, fine. Universal instantiation. Nag-consider siya ng random x. And then, he supposed that x plus 9 over x is greater than or equal to 6. And then, nag-multiply siya both sides ng x, which is fine. Hindi niya binago yung inequality kasi positive si x. Right? And then from here, oh, it's clear. X squared minus 6x plus 9 greater than or equal to 0. And then here, okay. So this is, I can factor this as x minus 3 cubed greater than or equal to 0, which we know to be true. Why is this not a correct proof? Oh, yes, Gad?
Sir, kasi yung proof po niya, nag-start siya sa conclusion. And it will not make sense if magpo-prove tayo tapos magsisimula sa conclusion dahil wala na tayo ipo-prove. Kasi sinabi na natin na yung
Okay.
yung dito,
So
yung
medyo
pinoprove po natin
choppy
is
yung reception ko, Gad. Okay, but I think,
okay na.
thank you, Gad. But I think I get the gist of what you're saying. You're saying that mali yung proof kasi ginamit niya yung gusto talagang i-prove. So if you will assume that the conclusion is true, then there's nothing left to prove. And actually, I won't even say na wala ka nang dapat na i-prove, pero from the get-go, mali yung proof. Kasi nagsimula ka dun sa pag-assume na totoo yung conclusion. But remember, when we do proofs of validity, ina-assume lang natin, remember yung two-column proof, nililista lang natin yung premises. So sila lang yung ina-assume natin to be true. Nowhere in our strategy then did we assume that the conclusion to be true. Hindi natin ina-assume yung conclusion. And yet here you are, supposing the very statement that you want to prove at the beginning. So bakit mo i-assume yung gusto mong ipakita? Eh yun nga yung gusto mong palabasin mula dun sa assumptions. So hindi ka pwedeng mag-start dito kasi yan yung gusto mong i-prove. Pwede mo lang gamitin as part of your premise, and part of your proof are things that are known to be true or follows from previously proven facts. Ito, wala tayong na-prove about that yet, and actually ito yung gusto nating i-prove. Okay? However, I think there's some value to it in what number 2 did. Pwede siyang maging preliminary analysis. Kasi pwede mo sabihin, oh, this is my target. And then dahil lang assumption ko naman si X ay positive, pwede ako mag-multiply both sides. Okay? Kaya ako ito makukuha by X. And then I can do transposition. I get this. And then I can factor the right, and I will come up with something is true. Tapos by conditional ang inequalities. Tama? So this goes both ways. So ibig sabihin, kung dito ako mag-start, pwede kong gamitin yung isang arrow nung biconditional statement. Starting from here, I can get here. Oh, biconditional ulit. So pwede akong pumunta dun sa previous line. And then biconditional ulit, pwede akong pumunta dun sa previous line, which is what I wanted to prove. So basically, this is, I will call it a preliminary analysis, because here we are analyzing what is that we want to prove, okay? And then try to come up or to come up with an argument or a body of argumentation, usually a biconditional statement that will lead us, starting from what we want to show, using biconditional facts, tapos makaka-arrive tayo with something that is known to be always true. Tapos gagamitin ko yung fact na biconditional lahat ng ginawa ko. So pwede ako mag-start dito, which I know to be true, and then mag-work ako backwards. And again, working backwards is guaranteed kasi biconditional yung mga statement ko. And I think this is the reason how we knew from the beginning to start with x minus 3 quantity squared greater than or equal to 0 in this proof. And then yung preliminary analysis, usually hindi na siya sinasama dun sa actual proof. Kaya kung makikita nyo, may mga proofs talaga na pag binasa nyo, parang ang galing. Out of nowhere, meron siyang pinagsimulan na isang statement that is known to be true. And then, surprisingly, from that statement, which appeared to have come from nowhere, naka-arrive tayo dun sa gusto nating conclusion. So the trick there is do a preliminary analysis. Okay. So let's try some more examples. Example 11. For all odd integers, a and b, a times b is also odd. So let's try to write the proof. Okay. Now, we are claiming that this statement, a times b is odd, is true for every odd integers a and b. So again, this is kind of a universally quantified predicate, wherein our domain is the set of all odd integers, right? So again, we start the proof. Since the statement is claiming that this is true for all odd integers, I will start my proof by assuming two odd integers. Let a and b be odd integers. So we are imposing nothing more to a and b aside from being odd integers. Okay. And then we want to show that a times b is also odd. Okay. Now, our only assumption here is that a and b are odd integers. So we need to think of ano ba yung characterizing property ng odd integers. So any idea? Ano yung pwede kong sabihan kay a and b, knowing only that they are odd? Oh, yes, Daniel.
We let them be a sum of a number times 2 plus 1. I
Okay,
get.
great. Good, Daniel. So yun yung characterizing property ng odd integers. So then since A and B are generic odd integers, then I can write A as say 2n plus 1 and B equals 2m plus 1, where n and m are arbitrary integers. Yun lang naman yung requirement para maging odd, right? Even plus 1 or 2 times an integer plus 1 is always odd. But be careful, si A and B, hindi natin alam kung parehas sila. And we want to keep the generality of the assumptions about A and B. So here I am assuming that A can be written as 2n plus 1. But when I write the same for B, I am using a different variable m. Kasi nga dapat generic sila. So n and m are not necessarily equal to each other. So hindi ko pwedeng sabihin na parehas silang 2n plus 1. Pero alam ko ganun yung form nila. So the safest route is to use different variables for that integer n. Okay? And then what do you think should I do next? Any idea? Any suggestions? Okay, Amy-san.
Ano po, try multiplying 2n plus 1 to 2m plus 1.
Okay, great. You, that's correct. So here, remember what we want to show is that A and B, A times B is odd. Alam ko na kung ano yung itsura ni A in expanded form. Alam ko na yung itsura ni B in expanded form. So I look at A times B, right? So probably I'll have note here, note that A times B is equal to 2n plus 1 times 2n plus 1. Kailangan nyo akong tulungan dito, maaga pa. So baka hindi pa gumagana ang multiplication ko. So hopefully tama. 4mn plus 2n plus 2m plus 1. Tama ba yung pagkakamultiply ko? Hopefully tama. Okay. And then here, since we want to show that this is odd, we want to write it in the same form. Twice an integer plus 1. But look at the first three terms. I can factor out the 2. So I'll have 2 times 2mn plus n plus m plus 1, which is of the form 2q plus 1 for some integer q. And actually, you can say, oh, I know what q is. Q is 2mn plus n plus m. But the bottom line here is, when I get A times B, I know that it will fall under the form 2q plus 1. And if you want to make pasikat, sabihin nyo pa, oh, si q ay 2mn plus n plus m. So, but that doesn't really matter because it is an integer. So I know that A times B just falls under the form 2q plus 1, which is basically the distinguishing property of odd integers. Okay, so therefore, you can say thus AB is odd, and that ends the proof. Okay, so let's analyze quickly what we did here. So again, this is a universally quantified statement for all odd integers A and B. So we started the proof by universally instantiating A and B. And then in the body of our proof, we use the distinguishing property of A and B being odd. Because there might be something to it why the statement insists that A and B should be odd in the first place. Or yeah, A and B should be odd in the first place. So dapat magamit natin yung pagiging odd nila. And if you think about it, the distinguishing property of odd integers is that they can be written as twice an integer plus 1. And then I'll go from there. I want to show that A times B is odd, so I will multiply A and B. And I'll look at their expanded form and keep my fingers crossed, and hopefully in the end, I'll be able to write AB as 2q plus 1. And indeed, we have done that, and that completes our proof. Okay. I hope everything is going well so far. Okay. Let's look at example 12. Again, this example is universally quantified because here we are looking to prove that this statement is true for every integer n. And that statement is n squared plus n is even. And this is a little bit more generic than the previous example kasi si n daw ay integer. However, ang problema doon ay ano ba yung characterizing property of integers? Integer siya kapag siya ay whole number, right? Pero we cannot say anything more about that. And look at this statement. Gusto nating ipakita ni si n squared plus n ay even. So the way to do it is to show, okay? So we want to show that n squared plus n is even. So that is the same as saying that n squared plus n is equal to 2q for some integer q, right? Kasi gusto nating mapakita ito ay even, so dapat masulat natin siya as 2 times q, where q is some integer. Ang problema, we don't know how to expand the integer n. Kasi integer lang yung alam natin sa kanya, there's no other form to it. Okay? So this is an example wherein we cannot prove the entire statement in one go. So kasi yung pagiging integer, wala siyang ganong kalaking information na maibibigay sa atin. So in such cases wherein the domain is quite broad and there is no useful characteristic that binds all elements of that domain, right? Pwede mong hatiin yung domain into two subdomains that will include all of the elements of the original domain, but these subdomains will have some nicer properties among themselves. So ibig sabihin, imbes na i-consider natin o isulat natin yung proof para sa lahat ng integer, bakit hindi natin i-try isulat muna yung proof para say sa mga even integers. Tapos gawin natin siya para sa mga odd integers. If we'll be able to show that this statement is true for both of these classes, then we're done. Kasi napakita pa rin natin siya sa lahat ng integer n. Yun nga lang, naghati ako sa cases. Kasi ang problema ko ay napaka-generic, napaka-broad nung statement na every integer. I have no way of expounding on the properties of n, aside from knowing that it is an integer. Mas gusto ko mag-work kung bibigyan ko ng properties si n, aside from being an integer. Pero I still need to consider all the cases para makover ko yung lahat ng integers n. And let's look at the strategy here. Una, sinupose ko si n ay even. Gusto ko tong gawin kasi kapag si n ay even, alam ko na masusulat ko siya na 2k for some integer k. Right? And so I can replace all n's in n squared plus n by 2k. So remember our goal, we want to show that this is twice some integer. So palitan ko si n ng 2k. So I'll have 2k quantity squared plus 2k, and that would be equal to 4k squared plus 2k. And here you can factor out the 2, so you can write it as 2 times 2k squared plus k. K is an integer. K squared will become an integer. 2k squared is an integer, so 2k squared plus k is an integer. So ultimately, we have shown na kapag si n ay even, yung n squared plus n ay even din kasi it's 2 times an integer. So at least in case number 1, we were able to show that the statement is true whenever n is even. Pero hindi doon natatapos yung proof because the statement is asking us to prove it for every integer n. What we have done so far in case number 1 is to prove that the statement is true sa lahat ng even. So kailangan pa nating i-consider yung mga natitira. And true enough, if you assume that n is odd, it will admit an expansion to L plus 1 for some integer L. You do the same thing, but this time replace all n's in n squared plus n by 2L plus 1. And ultimately, if you do the calculations, you'll be able to show that this is what? I guess, yeah, you'll get this guy. And here we have shown that n squared plus n is 2 times another integer. namely the integer 2l squared plus 3l plus 1. And so even if n is an odd integer, n squared plus n is also even. And so that completes our proof kasi na-cover na natin lahat ng posibleng values ni n. N can be even or it can be odd, but nothing more. Yun lang yung dalawang options. But in both of these cases, we have shown that the statement is true. Okay? So nakita nyo yung pinagkaiba nito with the previous examples. Because here, wala tayong way, o wala tayong ibang expansion para kay n. Wala na tayong alam na iba sa kanya aside from being an integer. So that's why we go deeper and look at classes of integers. But make sure that when you divide your proof into cases, make sure that you have covered all the possible cases. Okay? Is that clear? Okay, thank you. Okay, so let's try exercise 13 quickly. Prove that for every positive integer, n squared plus 4n plus 3 is not a prime. Okay, I'm thinking bakit siya nandito sa case na to. Pero how do you think I can prove exercise 13? Anong gusto nating ipakita? Si n squared plus 4n plus 3 ay hindi prime. Oh yes, I saw somebody raise their hand. Or na-press lang ba? Oh, go Alisa. Any suggestion?
Ipag-separate po yung function to n plus 1 tsaka n plus 3.
Sorry, Alisa, I think my audio is bad. So sorry, hindi ko masyado narinig. Can you try to repeat it?
Chat ka na lang po, sir.
Ayan. Pero clear yung sinabi mo na i-chat mo na lang.
Ayun po, gawin pong 2n plus 1 tsaka n plus 3.
N plus 1 and n plus 3. Yeah, I guess you mean i-factor siya, right? So, let's see. So, of course, n squared plus 4n plus 3 can be factored using our algebra tools as n plus 1 times n plus 3. And again, anong requirement para maging prime? Dapat siya ay prime kapag meron siyang ibang factors aside from 1 and itself. Alright? So si n squared plus 4n plus 3, whatever n is, as long as it is a positive integer, then it can be written as n plus 1 times n plus 3. Now, may posibilidad ba na one of these factors is equal to 1? So kailan lang magiging 1 itong first factor? Magiging 1 lang siya kapag si n ay 0. Pero si n ay positive integer daw. So this factor cannot be equal to 0. And n plus 3 will be equal to 1 if n is equal to negative 2. Pero si n ay positive integer. So ibig sabihin, neither of these factors is equal to 0. Right? Is equal to 1. So ibig sabihin, nakakita tayo ng factor ni n squared plus 4n plus 3 na hindi equal kay 1. And so indeed, n squared plus 4n plus 3 is not a prime number because there is a factor that is not equal to 1. Or there's a factorization of n squared plus 4n plus 3 that doesn't involve 1 and the number itself. Okay? Kaya napaisip ako kung bakit nandito siya sa after nung breaking down into cases. Probably dun pa to sa taas. Kasi hindi ko naman kailangan ng cases, right? So, baka kasi iniisip ng theorem gagawin ko pa na n is even saka n is odd. But Alisa is correct. This simple factorization is enough. You just need to convince me that neither of these two factors is equal to 1. Okay? Now, let's try to move on. Okay. Let's try example 14. Example 14, prove that there exists a real number x such that for every real number y, this is true. Well, medyo kakaiba tong statement na to kasi iba yung form na pina-follow nung statement. The statement is saying that we want to prove that there exists a real number x. So existence lang siya. So kapag ka nakapagpakita ka ng isang real number x that satisfies what is to follow, then you are done. Because again, this is existential. Sinasabi niya may nag-exist na x such that sa kahit na anong y, totoo dapat itong equation na to. So y should be kept generic. Pero ang hinahanap natin ay ano kaya yung number x na nag-hold para sa lahat ng y so that this equation will follow. Okay? So ano kaya yung x? Sabi nung proof, kunin mo lang x equals 4. And then kung kinuha mo na si xi equals 4, gusto ko ipakita na okay, ang claim ko ay 4, na ito ay totoo kapag ka si x ay 4 at saka si y ay isang arbitrary real number. And I need to keep y generic because look at the statement. There exists a real number x, may nag-exist na x, such that kung kahit anong real number si y, dapat totoo tong equation na to. So y should be kept generic, while I can give a specific value of x that will work for any generic y. And if I'll be able to show that there is one x, at least one x, na totoo sa lahat ng y, etong equation na to, then I'm done. Specifically, the proof let us know na x equals 4 is enough. Because when I plug in x equals 4 to the left-hand side, and again, look at how the proof was written. I started with one side of the equation. I did not start with a full equation and then plug in 4 because that would be wrong. I don't want to put in my proof anything that looks like the conclusion as is, right? So kaya kinopya ko muna to. Doon ako nag-start. Ang goal ko mapakita na equal siya kay y. Okay? So I got this, and then I am claiming that x equals 4 is the desired value of x, or is one of the desired values for x. So palitan ko lang yung lahat ng x's by 4. And then if I simplify this, I get y. And so that ends the proof. Okay, so you can write your proofs this way. Kasi sabi lang may nag-exist. So i-demonstrate nyo lang talaga na may nag-exist na x. You don't need to show me the preliminary steps you did. How did you get 4? I don't care in proving. So pwedeng ganito lang talaga yung proof. Hindi nyo na ipakita kung saan nyo nakuha si 4. Okay? Ipakita nyo lang na nasa-satisfy ni 4 yung equation sa kahit anong given value of y. I don't need to see what are your scratch work on how you found 4. That's an example of a preliminary analysis. So, ginawa nyo lang sa prelim analysis, eto lang, nagsimula siya dun sa gustong equation, and then sinolve niya lang si x. You can do your usual algebra tricks. Kaya nyo isolve dito si x. Makukuha nyo x equals 4. Sa kahit ano pang y, kasi sort of parang makakancel lang naman yung mga y's dito. Or all expressions involving y will get canceled. So, matitira lang ay x equals 4. And that is preliminary analysis. Okay? So, please try exercise 16 when you have the time. Ganun din, gawa muna kayo ng prelim analysis, tas kailangan makahanap kayo ng integer m na totoo ito sa kahit anong n. So again, the prelim analysis will require you to solve for m in this particular equation, and then you write the proof in a very similar fashion as the proof of example 14. Okay. Now, let's try the next one. Okay. Now, look at example 17. Ano yung kaibahan niya mula dun sa mga previous statements that we considered? So if we read the statement carefully, we want to prove that for every real number x, okay, so universal. So kailangan magbigay tayo sa proof. Dapat magbigay muna tayo ng isang arbitrary real number x. That is where we will start. And then we want to show that there exists a number y such that this is true. So sa kada isang x, sa kahit na anong real number x, may nag-exist daw na real number y. So it looks like that the existence of the number y is dependent on x. So kasi sa bawat real number, isa-isahin mo sila, merong mag-exist na corresponding y. So posible na yung value ni y na hinahanap natin ay maging depende doon sa value ni x. Kasi sinasabi niya, for every real number x, pag binigyan ko kayo ng real number x, kaya nyo akong bigyan ng real number y such that this is true. Which is different from the previous example na for all x, there exists an x such that for all y. Ngayon, nabaliktad. Nauna muna yung existential quantifier. So, sinasabi nito, may nag-exist na x, sa kahit na nung x, may nag-exist na y. So, pwede nating isolve si y sa kahit na anong number x. And then the answer for y might involve the number x. Okay? Now, let's see. Let's try a preliminary analysis for this. So ito yung gusto nating mangyari, x squared y plus 2x equals x. But then, si x ay arbitrary, so kailangan ko mahanap ano yung y na kapartner ng any given x. So essentially, what I want to do here is to solve for y in terms of x. And if I do that, I'll get x squared y equals negative x. And then I divide both sides by x squared to isolate y on one side. But there I provided that x is not equal to 0. Kasi kung si x ay 0, hindi mag-work yung dividing both sides by x. And then essentially here we get y is equal to negative 1 over x. And then we need to think, okay ba to na candidate para kay y? Okay? So you need to go back to the statement again. Pag binigyan daw ako ng x, dapat may magko-correspond na y. So given si x in the first place. Alright? Hinahanap natin yung kapartner niya na y, which might depend on the value of x. And true enough, when we did the preliminary analysis, we have seen na si y ay equal kay negative 1 over x. Okay? Now, but you see, I have an exclusion here. X cannot be equal to 0. Mag-work yung analysis na to kapag si x ay hindi equal kay 0. Okay? So, kailangan kong hatiin yung proof sa dalawa. And this preliminary analysis gives me an idea how to do the first part of the proof. And that's what case 1 is. If x is not equal to 0, then yung value ni y ay negative 1 over x. And again, this is fine because in the beginning, x is given. So, halimbawa, si x ay 1/2. So, si y ay negative 1 over 1/2, so which is negative 2. If x is 10, then y is equal to negative 1 over 10. So parang challenge si x, response si y. Pero nauunang mabigay si x. So kapag ka nabigay si x, pwedeng si y mo sabihin mo, it's a function of x, namely it's negative 1 over x. And true enough, again, I want to show that that value of y will make this equation true. So magsimula ako sa left-hand side niya, plug in y, and show that that will be equal to x eventually. Okay? But that is not the end of the proof because this only works when x is not equal to 0. Okay? But if x is 0, what happens? So if x is 0, pwede nyo simulan, oh, x is 0 pala, so I'll have 0 squared times y. So prelim analysis ulito. Plus 2 times 0 is equal to 0. So that means I'll have 0 equals 0, an identity. All right? So sa preliminary analysis, nakita ko na pag pinlogin ko si 0, dun sa gusto kong equation na maging totoo, I'll get an identity. Kapag nakakuha ka ng identity or something that is always true or tautology, para magamit natin yung mga terms natin sa logic, naka-arrive tayo sa isang tautology. So ibig sabihin si y kahit anong value niya pwede. So you can say, oh, I will choose y to be 17, my favorite number. So pwede nyo sabihin if x is 0, that will give me here, I can take y equals 17. So I'll have 0 squared times 17 plus 2 times 0. And that will be 0 plus 0. That would be equal to 0. Statement is still true because 0 is equal to x. All right. So those are the two cases. And I guess we have covered everything there. So that ends the proof. So kung nakikita nyo, depende talaga yung atake dun sa proof o yung form ng proof, depende dun sa statement. Ano yung mga nauuna na quantifiers? Kasi they will really make the difference. Again, if you want to go by the book, nakasulat dun sa worktext yung classification sa bawat isang statement. But I always go through understanding what really the statement is claiming because intuitive naman yung mga kailangan natin gawin. Okay? I mean, you don't need to know the exact formal symbolic form of the statement, pero pag naintindihan mo kung ano yung gusto niyang sabihin, ano yung kiniklaim niya, then I think that is enough for you to know the approach or the right attack to prove this given statement. Okay? There's a question in the chat. Charles is asking, ano po ang magiging value ng y to solve for x? Santa Charles, eto ba yung dito sa example 17?
Ano po, sir, dun po sa 1.5.4 po.
Example.
Yung previous po.
Ito? Sa 14?
Yes po, sir. Dun po.
All right. So here is ano yung magiging value ni y. The thing here is that kung mabasahin uli natin yung statement, prove that there exists a real number x such that for every real number y, universal yung quantifier ni y. So for every real number y, so hindi tayo pwedeng mag-assign ng isang specific value kay y. Kasi dapat daw totoo itong statement na to sa lahat ng real number y. So hindi ako pwedeng mag-assign ng isang value kay y. Hindi ko siya pwedeng palitan by any other form because all I know about y is that it should be a generic real number. And luckily, medyo mabigat nga. Tama ka, Charles. Mabigat yung statement ng 14. Kasi hindi lahat ng equation kaya nating isolve si x given y. Kasi usually y and x will depend on each other, right? Pero luckily, medyo simple yung equation. So, ginawa dun sa prelim analysis, gusto mo makita ng x, di ba? Existence ng x, na totoo siya sa lahat ng y. So, ang ginawa, solve ko to. I'm hoping, fingers crossed, that all y's will be gone. Kasi si y ay generic real number. So, I don't want to deal with y kasi generic nga siya na real number. Hopefully, makancel siya. And true enough here, ano yung mangyayari? We're solving for x. So ititira ko lang lahat ng may x sa left side. Tapos lahat ng walang x ilalagay ko sa kanan. Kasi I'm solving for x in terms of y, but hopefully the y's will be gone. Kasi dapat si y ay generic. Dapat wala siyang pinaplay na role kay x. Or pwede naman, pero hindi dapat ganun ka-imposing. Kasi dapat totoo yung equation sa isang x at lahat ng y. Okay? So here I'll get y plus 3y plus 12. So on the left, I can factor the x out. Y minus 3. And here I'll have 4y plus 12. But I can factor out the 4. Okay? And then, oops, anong mali? Okay. Dapat minus 12. Sabi ko sa inyo, maaga pa eh. So, bantayan niyo yung algebra ko. So, yan, minus 3. Tapos, meron akong x. Meron ako nito. Yan. And then, I can divide both sides by y minus 3. Okay. So, that means x is equal, indeed, to 4. All right. Provided that y minus 3 supposedly is not equal to 0. Okay. So that means y cannot be equal to 3. Pero if y is equal to 3, mag-hold pa rin ba yung 4? Kasi if x is equal to 3, this guy will be 0, This guy will be 0. X can be any number because you'll have x times 0 equals 4 times 0, which is 0 equals 0. That's true anyway for y equals 3. Okay? But ang gusto ko dapat totoo siya sa lahat ng y's. Pag si y ay hindi equal kay 3, nagiging totoo lang yung statement kapag ka si x ay 4. Pero kapag ka si y ay equal kay 3, itong equation ay magiging totoo sa kahit na anong x. Pero ang usapan, dapat totoo yung equation sa lahat ng y. So ang pipiliin ko na value ni x ay 4. Kasi si 4, magiging totoo yung equation kapag ka si y ay hindi equal kay 3 at magiging totoo rin kapag ka si y ay equal kay 3. I cannot just give any value for x, say 17. Though 17 will work if y is equal to 3 kasi magkakaroon ka ng 17 times 0 equals 4 times 0, which is 0 equals 0. Pero kapag ka si y ay hindi na equal kay 3, 17 will not make this statement true. Okay? So I hope that answers your question, Charles. Medyo lucky tayo dun sa equation kasi na-solve natin si x independent of y or sort of independent in y. Okay, if that's okay, I'll go to the next question. Sir, kapag po ba nakakuha ng equality sa dulo kahit arbitrary yung y, will that always mean that it is true for any y? Yes, that's right, Mary. Kapag ka nakakuha ka ng equality sa dulo, using any arbitrary y, meaning wala kang inimpose na ibang condition kay y aside from being an element of the domain, then that means your statement is true sa lahat ng y. Kasi wala kang impositions kay y na iba aside from being an element of the domain. So you're good with that, Mary. Sorry, overtime na naman, but I hope you're enjoying the classes kasi wala pa nagli-leave. So I'll take that as medyo nag-enjoy pa kayo. Okay, I think medyo marami pa pala akong naiwan uli. Bagal ko magturo, no? Pero I think this is fine. Ganun talaga pag nag-enjoy ka, no? Marami ka masyadong nasasabi. So perhaps still on Thursday, we'll still be on direct proofs, proving quantified conditional statements. So let's do this. So kung sinusundan niyo yung study guides, I'm sorry, but mukhang nasa study guide for week 4 pa rin tayo hanggang sa Thursday. I don't wanna skip details, so I want to be as meticulous as possible kasi nga ito yung bread and butter nyo. So next time we'll look at direct proofs. Hopefully makatouch din ako ng something about study guide for week 5 next meeting. All right. But we'll do proving quantified conditional statements and their contrapositive on Thursday. Okay. All right. So any other questions, guys? Sorry, overtime na naman ako by 10 minutes. Kasi dati, di ba sa face-to-face, I need to dismiss you 10 minutes before the time to give you time para maglakad dun sa susunod yung building. Pero dahil ngayon kayo ay nagsuswitch lang naman ng Zoom room, so I think that's fine. But sorry, kinuha ko na naman yung 10 minutes yung sana na break. Let's talk about submission of worksheet 5 next time. So, pero if you can answer some of the problems from worksheet 5 this week, then that's fine. Mas okay. Pero depende sa matatapos natin sa Thursday kung ano yung isa-submit. Pero kung may na-cover na tayo na coverage ng week 5, ng worksheet 5, most probably papasubmit ko na siya sa inyo sa Monday para hindi tumambak yung mga worksheets natin. So try it out. Kailangan lang naman namin ay valid attempt. So it will also be a good exercise on your part para yun na rin yung magiging review nyo for the problem set. Okay? So any other concerns? Kung wala na, then thank you for waking up early this morning and and I hope you enjoy the rest of the day. And let's see each other again on Thursday. Bye, everyone.
Thank you, sir.
Oh, by the way,
Thank you po, sir.
Thank you po, sir.
Thank you po.
Thank you po, sir.
Thank you, sir.
okay. Yung mga nag-recite pala, pa-comment naman sa chat. Baka hindi ko ma-record.
Hindi po ako makakapag-chat po.
Sino yan? Si Gad? Oh yeah, Gad, na-comment ko na yung pangalan mo.
Okay
But
po,
the
thank you
others,
po.